Okay, in this section we are going to look at two exercises that are near the end of the list. The first one is exercise 83. Show that the graph of the function f of x equals 3x plus sine x plus 2 does not have a horizontal tangent line. So what does this graph look like? We don't know necessarily, but we can think about what it may look like. Actually, 3x is a line, it's pretty steep. Sine x is a wave, it looks kind of like this. And then 2 is a constant line like this. So if we add these three graphs together, what's going to happen? Well, the plus 2 is going to change the graph. It's going to lift it up by 2 units, but it's not going to do anything to the slope of the graph. So if we're looking at the slope, we need to add these two graphs really. And what we may feel already, even though it's not obvious and we have to solve this exercise algebraically, we may realize that the slope here is so steep that it's never going to be compensated. So my rough sketch of what the sum of these three graphs is, so we're going to have to go through two. This is the line, and then if I add some kind of sign, it's going to look somewhat like that. So the graph that we're going to end up with is kind of snaky, but the point is there is no place where the tangent line is horizontal. So the question that is asked is not to sketch this graph, but I think it's interesting to realize that we can try and do that. How are we going to figure out whether there's a horizontal tangent line or not? We need to remember that a horizontal tangent line means that f prime of x equals to 0, and vice versa. So if we calculate the derivative, what we get is the derivative of 3x is 3, the derivative of sine x is cosine x, the derivative of plus 2 is 0, and here I am with an expression f prime of x equals 3 plus cosine x, where I'm going to be wondering whether this is true or where it's true. And in fact, if you move the negative 3, you realize that you're supposed to find a value of x where cosine x equals to 3, and that's not possible, right? So what it means is there is nowhere where the tangent line to the graph is going to be horizontal. The smallest slope is still positive. Okay, so remember this, that's very important. Horizontal tangent line means that f prime of x is equal to 0. The second problem that I want to review is exercise 121. In that exercise, we have to find a and b such that the function f given by a piecewise function is differentiable. You may remember that when we have two unknowns like a and b here, in math it means we need two conditions. We can have one condition and that's going to give us one of the unknowns, and the second condition is going to give us the second unknown. So we need an equivalence between the number of conditions and the number of unknowns. Here, it looks like we only have one thing we need to satisfy. We need to have f differentiable. But that's actually two conditions in disguise, because if f is differentiable, it automatically means that f is continuous. If f is not continuous, then it is not differentiable. So in fact, we have two specific elements that we can use. I'm going to start with f continuous. If f is continuous, what it means is that at x equals to 2, this expression here has to be equal to that expression, so that the two parts of the graph are actually touching each other. So a times 2 cubed has to be equal to 2 squared plus b. If I solve this, I get 8a equals 4 plus b. So the first condition yields some information, but it's not enough. We need to use the second one. F is differentiable, which means that the derivative of f has to give the same value for the first rule and the second rule. Let's find out what the derivative of f is. This is also a piecewise function. On the left, for values less than or equal to 2, we are going to have a derivative of 3ax squared. On the right, for values of x greater than 2, the derivative is going to be 2x. 2x plus 0. So because we want it to be differentiable, it means that at x equals 2 there is going to be a derivative. So that's why I can put the equal sign here, because we know there must be a value that is correct, or a value that matches these two rules at x equals 2. Let's see what we can do. 3a times 2 squared equals 2 times 2. 3a times 4, 12a equals 4. From there, I find that a equals 1 over 3. It may have happened that I have a system of equations. Here I have one equation with a and b. Here I may have had another equation with a and b, and then I have to solve the system. But in this particular case, I can find a directly, and now in order to find b, I'm going to plug in a up here. 8 times 1/3 equals 4 plus b. So 8 over 3 equals 4 plus b, and therefore b equals 8 over 3 minus 12 over 3, negative 4 over 3. Okay, so if we want to be neat, we can write the function again. It is the function 1 over 3x cubed for values of x less than 2, and it's x squared minus 4 over 3 for values of x greater than 2. There we go. Thank you very much.